All right, so we're going to look at just a couple of examples. First example is a random sample of size 45 is taken from a population that has a known mean and standard deviation. The question is, find the probability that the mean of our sample is less than 59. Okay, so this could be, for example, you know some information about a population, you go ask them about who they're going to vote for, what is the probability that they're going to be outside of the normal average. Okay, so if I get something that I expect is a really weird answer, well, what's the probability that that's the case? And we'll look more into this. That's basically what the rest of the option is looking into, okay, what's the probability that there's a mistake in the error, what's the type of error, that kind of thing. That's all that we're doing for the rest of the option for the next month or so. Okay, so what do we know?
The mean standard deviation and number.
I know the mean and standard deviation of the population. What else?
The size of the population.
I don't know the size of the population,
The size of the sample.
but I know that I'm going to ask 45 people. Why is 45 significant? It is larger than 30. What does that mean?
It's approximately under normal distribution.
It means that I expect that the averages, the means, should have a normal distribution. Okay? So I expect that the average is 60. So the question is, what's the probability that I'm going to get an answer less than 59? Okay? Now, this is the standard deviation of the population. That's not what I want right now. I want what is the standard deviation of my sample. Okay? So how do I get that? Right here. The variance in the means, because my value, this 59, is the average value for all those questions that I'm asking, whatever it is. So that variance will be equal to the variance of the population divided by how many trials. Remember, for every trial I make, I expect my results to be closer to the mean. Okay, so that's what I'm going to do. I'm going to say the variance of x bar is equal to sigma, which is 4 squared over the number, which is 45. So what is going to be the variance of x bar? 16 over 45, which I'm okay with just leaving it that way. So therefore, the standard deviation of x bar is the square root of that, right? So 4 over the square root of 45. So now, knowing the standard deviation and knowing the mean, can you now calculate the value of the probability of getting below 59 using norm CDF on your calculator? What's up?
What do you need for norm C?
You need the mean and you need the variance, standard deviation. Johan, you got me a number?
0.04676.
0 point what?
0.4676.
Okay, and I'm going to leave it at 3 because that's what IB asked me to do. I need confirmation.
Oh, yeah.
Is that what you got?
Yeah.
Oliver got that too. How about you, Diane?
I put in the wrong numbers on here.
So you did not get that number.
No, I typed in the wrong values. Like, maybe it was
Got it. Sweet. Am I there? So if I were to do this survey, and my answer that I got after doing all this survey was a number less than 59, what would I think? After asking these 45 people and I got an average below 59, what should be going on in my head right now?
It's highly unlikely.
It's highly unlikely. One of two things must be wrong. Either I messed up, because there's a 5% chance of me getting a value less than 59. It's possible, but it's not likely, right? So either I messed up, or what else could be wrong? This could be wrong. What we assumed was the correct mean and what we assumed was the correct standard deviation could be incorrect, right? So it doesn't necessarily mean that I'm wrong, because we all know how likely that is. It could mean that they're wrong, okay? So keep that in mind, and that's the thing with statistics, is that statistics describe something based off of whatever assumptions and whatever beliefs you started with, okay? Awesome, we got a couple more minutes, let's do at least one more. Okay, we've got a large number of samples of size n taken from a Poisson distribution. That's Poisson, that should be a 2.5, I don't know if you can see that decimal. About 5% of the sample means are less than 2.025. Estimate n. So, tell me about my sample means.
2.5. 4.
The mean of my sample means should be 2.5, right? Because that is the mean of the Poisson distribution. However, the distribution of the sample means should be
Normal.
a normal distribution. So I've got a normal distribution, a mean of 2.5. What is going to be the standard deviation of my sample means?
Square root of 2.5 over n.
Is everybody okay with that? Because that is the variance of the initial population, right? Divided by n.
Shouldn't the square root roots include the n? Because the variance is sigma squared.
Yes, yes, sorry. Yeah, I was thinking of what we did here, where it was just standard deviation of that. But you're right, that is the variance. Okay, what else? Because I don't know either of those right now.
You can find the variance
How can I do that?
using inverse norm of the z-score.
Okay, because they told me that 5% of the sample means are less than 2.025. So that's down here, 2.025, and it's saying that this right here has a probability of 0.05. And so using inverse norm, I don't actually need the z-score because I have the mean and variance, but I can use that to calculate variance. Actually, I do need it because I don't have standard deviation. I'm sorry, you're correct. Because I don't have what I'm looking for. I know the mean. So I can use that to find the z-score. Can you do that on your calculator, please? Let's get the z-score for that.
Negative 1.64485. 644.
Okay, I'm okay with that. That's an intermediate number, no problem. So negative 1.64485. We put in a probability of 0.05. We got the z-score directly from that, right? We left the mean as 0. We left the standard deviation as 1, and that allowed us to get the z-score. Remember, that's how we do the inverse norm. So we did inverse norm, probability 0.5, mean 0, standard deviation 1. That gave me a z-score. Now that I have the z-score, I can go z-score equals,
It's minus
x minus our mean over sigma.
It's negative 1.612, not negative 1.6.
Not this?
He put an actual mean.
Oh. So what is it really?
Negative 1.61213.
Okay. Why don't we put the real mean there? You said the first time you put this mean. So why don't we put that there?
We didn't.
Oh, you didn't? Oh.
Oh, he did. I did.
Yeah, that's what I'm saying. Why don't we put that there?
He did.
Yeah.
So we shouldn't?
No, you shouldn't.
The
That's
thing
why I'm
is-
asking. Why don't we put that number there?
Because it's the it's like the general. It's how many standard deviations away.
This is only valuable if we know the standard deviation, right? If we don't know the standard deviation, then this number itself, the 2.5, is not helpful in finding our z-score, right? If we have this number and if we have the standard deviation, we don't need the z-score. We just get our answer, right? But if we are missing one of the two, then you just assume 1 and 0. And that will give you the z-score, which then allows us to find the other one.
So annoying.
Okay? So here we should be able to then go negative 1.61213.
Negative 1.644. I asked you and you said it was okay.
I
I
don't
still
know.
give
You
up.
always make me second guess myself.
Wow.
Wait, Freddy's about to finish it.
Okay, so what's the real number?
This is 4.4. Negative 1.64 is negative 1.64485.
And that is using a mean of 0
Yes.
and standard deviation of 1, because that's how you get a z-score. Okay. Why can I not use this number?
Because that's the it's
But why can I not use this one? Why can't I use that to get this number here?
because we're finding the z-score, not the.
Okay, and why am I getting the z-score, not the actual number?
We're not. That's
Because
not
you're
what
trying to find
the other.
Because I don't have this standard deviation. If I had that, then I would use it. I would use those two numbers. I wouldn't use the z-score. The z-score is only important if you're missing one of those two numbers, either the standard deviation or the mean. Okay? But since we only have one, we have to go z-score. Then we solve. So 1.64485 is equal to 2.025 minus the mean 2.5, which then allows us to find this number. Once you have that, you put it in here and you solve for n.
Is the answer 30?
The answer should be 30.
Okay.
Okay? So I'll let you finish that at home. Make sure you can get to 30. This right here is called the sample error. Even though it's the standard deviation, there's a special name for it. Okay, so you need to recognize that term, okay, because that will be used sometimes. It will tell you that the sampling error. It'll say the sampling error is this, instead of telling you that it's standard deviation. So make sure that you know sampling error is the standard deviation of the sample mean.